In this video, we're going to learn how to simplify logarithms. Now, there are a few properties we can use with logarithms whenever you have a product within a logarithm, a quotient within a logarithm, or a power within a logarithm. Now, whenever there is a product within a logarithm, you can split up those logarithms into two other logarithms, log base b of m plus log base b of n, and that equals log base b of m times n. Now, conversely, if you had two logs being added together, you can combine them into one, to where m times n is within the log base b. Now, where this property comes from, the product property, is the same as the product property for exponents, because we have b to the m times b to the n, like the m times n here. You would add the exponents, and if you remember that logs are equal to the exponents, this makes a lot of sense. Now we have a quotient. We know about dividing two terms with exponents. We subtract their exponents. So if there's a quotient within a log, we can subtract both those factors into two separate logs that are being subtracted from one another. In the power property, we know that when we raise a power to a power, we multiply the exponents. So if there's a number raised to a power, we can move that power to the front of the logarithm. So we have n times the power here, log base b of m. So when you simplify, typically you want to rewrite it as a single logarithm and then see how much further you can simplify. So here we're actually going to start with what is the right side of the equation for these properties and go to the left side in terms of condensing it to one. So I'll start with log base 4 of 32 is equal to log base 4 of 32 minus log base 4 of 2. So if I want to rewrite this as a single logarithm, I notice that there is subtraction, so I can rewrite this as log base 4, keeping that same base, of 32 divided by 2. And 32 divided by 2 is 16. So if I wanted to finish simplifying, I'm asking myself the question, what power do I need to raise 4 to get 16? And if you recognize that 16 is 4 squared, you'll know that log base 4 of 16 is 2. So this expression just simplified to 2. Now let's say we have 6 log base 2 of x plus 5 log base 2 of y. Well, since I'm multiplying a number in front of the logarithm, I can move the 6 into the logarithm, leave me with log base 2 of x to the 6th power plus the 5 that's in front of the other log can move in to be the power for y using that same property. So I can get log base 2 of y to the 5th. And now both these logs are being added together. So those can further be combined to be just a single logarithm base 2 of both of those factors multiplied together. So x to the 6th times y to the 5th. And we can't simplify any further since we don't know what x and y are. So I'll just box that in as my final answer. Now let's get a little bit bigger with it. Let's say we have log base x for all of our terms. The first thing you want to do is distribute this 1/2 so we can move forward with simplifying. So I'll have 1/2 log base x of 4 plus 1/2 log base x of y minus 3 log base x of z. Now all three of these logs have a coefficient in front of them, so like the power property, those numbers in front can move into exponents of the number on the inside. So I can get 1/2 log base x of 4. Not 1/2 in the front. I'm moving it inside now, so I don't need that in front. So log base x of 4 to the 1/2 plus log base x of y to the 1/2 minus log base x of z to the 3rd. Now before I move forward, I'm going to simplify because anything to the 1/2 power is also known as a square root. So I have log base x of the square root of 4 plus log base x of the square root of y minus log base x of z cubed. Now the square root of 4 is 2. So I get log base x of 2 plus log base x of the square root of y minus log base x of z cubed. Now to combine these last terms, anything that's positive will be multiplied together. So I have log base x of 2 square roots of y minus log base x of z cubed, and any log being subtracted will divide that multiplication. So when these combine, I'll get log base x of 2 square roots of y all over z cubed. And to go back on that, whenever I subtracted two logarithms, it became division on the inside, where the thing you subtracted is in the denominator. That's why z cubed's in the denominator. And I'll box in this answer, and that is my simplified version. Now lastly, let's say I have a lot of variables going on. Now I don't have any coefficients in front, but I do see that the -1 is actually in between two positive terms. So if I wanted to combine all of these at once, I would get log base 3. The one being subtracted ends up being the denominator. So 3x squared minus 3x minus 6. And the ones that are positive end up multiplying together to be my numerator. So x plus 1 times x minus 2. Now to simplify this, I want to take a note for my numerator and factor my denominator as well to see if any factors can cancel out. So factoring my denominator, I have x plus 1 times x minus 2 in my numerator. In my denominator, I can factor out a 3. So I get x squared minus x minus 2. And then that quadratic can factor into two factors. Known as x plus 1 and x minus 2. The reason why I chose those factors, 1 times -2 is -2, and 1 plus -2 is -1 for that x. But we'll see here, every factor cancels, leaving me with not 3, but rather 1 over 3. So now the question becomes is if I can simplify this. What power do I raise the base to get 1/3? Now 1/3 is 1 over 3 to the first. If I bring it to the numerator, that's known as 3 to the -1. So that power you raise 3 to get 1/3 is -1. So log base 3 of 1/3 is -1. And that's when I've simplified that expression. And that is how you simplify logarithms.